Hello, everyone. Good morning. Thanks for coming. It's quite early, but quite excited. So, okay, cool. So we'll get started. So I'm Daniel. I work, as Ricardo was saying. Thanks for the introduction. I work at Schibsted. I'm a manager there. But I would like to talk about building teams to deliver your first billion requests, right? So it's quite unlikely that you'll do this alone. So I think that's. So, and we want to share some experience with you, right, of going through a journey to do that. So a bit about me, I'll be quick. So I work at Schibsted now, but I work especially in the media industry. I work in my own company as well. I did lecturing. And this is my public GitHub there. So, but this is kind of the public GitHub. So I code mostly at home because, managing teams or, doing management stuff is quite hard work, but still enjoying coding. So, yeah. So just a bit of the context, because actually there's been 2 talks from colleagues from Schibsted. A bit of context is that Schibsted actually is a marketplace and media company. We have a lot of products across the world, actually 20-something countries. And yeah, that's a bit of them. And some of the Spanish ones you're familiar with, I don't know, Fotocasa, Vivo, InfoJobs, etc. Right? And a few others I'm not mentioning because that's quite a few of them. But and that's quite a lot of work, to be fair. And it's like the mission would be is to say, okay, how can we deliver services, low-level services, infrastructure, engineering productivity, etc., to deliver billions of requests, right? To handle what all these marketplaces and media houses generate, all this traffic, right? So, and these low-level services, I would like to emphasize that this is. So the product teams can actually build amazing products, right? So this is worth remembering constantly, if you like, and no more. And again, I will speak about building teams to do these low-level services, right? If you like. But this is an effort shared with all engineering teams at Schibsted, and I would argue anywhere else, right? So it's not that you have some infrastructure or engineering productivity teams that do all this work. This is shared. And at Schibsted, we make a big point of sharing this effort, right? So it's shared with all engineering teams. That's quite important. So I would say, talk about the challenges. The first is that we have many distributed teams. The number of developers, it depends on who you ask. I would say it's between 1,000 and 2,000. Depends on how you count developers, product people, etc., etc. It's a bit besides the point. But there's many distributed teams. I was speaking to people from Brazil last night, and that kind of stuff. So, and that's quite a challenge, right? So it kind of adds up that when you build teams that fit in those contexts, this is a bit of an extra, fun stuff. So, and the other one is that this is random, by the way, but I was like putting figures all across the map, but there's lots of end users, right? So I'm missing end users here. But it's around 200 million or something across several countries, right? So if you count Spain or if you count France or Brazil or things like that, this adds up a lot of volume. So that's why we're kind of talking about billions of requests as if they were cakes or something. So, and I would say the third challenge is the mindset. So when you join this kind of level of, a number of developers and user traffic, you end up doing, I don't know, infrastructure or engineering productivity or other kind of low-level services. You end up saying users when you mean engineers, right? Because you have, I don't know, 1,000 engineers that use your services, or more than 1,000. And when you say end users, you mean customers. So I'll probably say this, so make sure we don't, get confused. At least I get confused all the time. So, but it's important to love them both. So you must love your end users. It's your business, but also love your users, which is the engineers, and actually product people as well, right? And finance and so forth. So I'll just want to speak about lessons learned. So I'll just dump some lessons that we learned by a challenge of building teams, low-level like infrastructure teams, to deliver low-level services to all these product people that deliver these amazing products, right? I'll start with the most important takeaway first. Typically, you do it at the end when you don't have enough time, so you go very quickly with the most important stuff. So I'll try the most important thing at the beginning for a change. And then a bit discuss a bit some basic stuff, or some ideas or some experience about building the teams and then making them grow. So I would argue that I would say it's important to create them if you like, but making them grow and going together with them as a manager or as a colleague or as a fellow engineer to their first, second, third, fourth, seventh, whatever, billion requests is what is important, right? And then kind of go through the takeaways again, because that's cool. So the most important one, I would say, if you have to leave and just get one thing, I would say is the building up on the fundamentals is really key, really important. That's a bit of a cliche, if you like, but I would say that's the most important takeaway. And of course, these ones, the typical things you ask at the interviews, like computing science fundamentals, coding, etc., etc. That's of course very important. We do ask this on the interviews, not exactly these ones, but you get the idea. And I would believe that as a computer scientist myself, this is important. But actually, I mean these others. So, what's anchoring? It's a psychological phenomenon, right? And it's like 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. And then you do estimation and you say, how many days will take? 5. That's a badly explained anchoring, but it is a psychological phenomenon that's real. And that's, I would say, for instance, the basis of poker planning. That's why poker planning is useful, because it removes anchoring, which is a very damaging cognitive process for some things. Opportunistic agents, emerging behavior, self-replicating ideas, how they work, how they propagate. Reward systems. If they are predictable or unpredictable, are they more or less effective? These are psychology or emerging behavior fundamentals. There are different views on them, like computer science as well. Extremely important to build teams to work in this environment. And I would say, myself, I know next to nothing about them. Right? So I would say this is extremely important, and at least my experience building teams in this context is that this has been extremely valuable. It doesn't give you recipes or solutions, but it tells you you're not alone when you face these challenges, right? And do we trust people when they ask? You ask someone for help. Do they trust you less or more afterwards? This is a psychological phenomenon. Do we know? There's plenty of literature about it, right? And this is just random questions I picked up from this personal list of books. I'll publish this online, so by the way, but you feel free to take notes or whatever, right? And this is basically fundamentals about from sociology, from psychology, from economic history and things like that. Game theory, addiction, important one, quite shocking. And there's things about people that talk about religion, so feel free to skip the religion bit, but actually amazing books about emerging behaviors. Awesome stuff. And there's some that don't fit in the slide, but there you go. So that's the most important thing. Then, because we have the most important thing, the rest we can have a chat, right? So that's pretty cool because now I'm relaxed. So building the teams, right? I would say that this is kind of obvious, but it's important to reinstate that be prepared to interview a lot. To build amazing teams, I would say that interviewing is the most important job after reading all these books I mentioned. Right? But I cannot stress how important this is. Right? And actually, I would say it's an obvious thing, but the experience so far at Chipster building quite big teams and stuff is that you have to have metrics on, I wouldn't say everything, but on many important things. So if hiring is important, you should have metrics about it, about the process. Right? Like you do with any process or an engineering process. If you have metrics about your systems, they are important. Why do you don't have metrics about your hiring? It's extremely important. Right? And I don't know, and you can take pages from product development, like conversion rate. People go to your website, you download your app, and do an action. 10% of people do the action, right? That's a conversion rate. That's also badly explained conversion rate. Some people probably know more than I do. What about the hiring conversion rate? Do you know your hiring conversion rate? How many people you interview and then actually hire? 10%, 1%, right? The other one is to allocate plenty of time for interviewing. It's a part-time job. In 2016, this is a metric I know because it affects me. I did 101 interviews. This is the metrics. I don't remember, but now I know because you go in the metrics. It feels like a long, quite a long time, a lot of hours, but actually it was a lot of hours. So it's 1 hour interviews, but you need the preparation, and then the feedback phase, and then the discussion. That's a lot of hours. But there's metrics. You know how much time you spend on it if you kind of care about the time what the heck you're doing, right? And this actually, if you do the math, is close to 1 every 2 working days. It's snowing, but it doesn't snow here not much. But if it's raining, or if you're tired, or if you still have to do the interview, right? So but it does deliver the results. You put the effort, I would argue that it does actually work. The other one is that it's a bit non-intuitive, is that when you've hired some people, you get started, awesome. Then you say, I have an amazing team, do containers. And engineering, as an engineer, I would like that we need quite a high degree of autonomy, right? You get handed a mission, and then you do your job. But if you are starting the team, you are on that team, and you are starting, even if you are the manager as well, actually getting the people to know each other, and to, even if they are veterans or whatever, right? Or there's a lot of senior people or some juniors, it doesn't matter. Give them a small task instead. 3 months, a task in a general sense, right? Instead of saying, okay, do containers, you just say, deliver me a Mesos cluster for this specific use case. It's top-down. It's a bit quite, very, very set. It really helps the team. And we have learned the hard way, to do it this way. Instead of, okay, I hire a bunch of brilliant infrastructure engineers and give them a blue sky mission. This is actually detrimental. And I would say we have learned the hard way. And once you fill the team and you have the metrics, the team is mature, feel free to open up the domains. They say, okay, solve containers, which is, solving containers is actually a very, very, very wide domain, right? So it's probably too wide. But I hope you see, you see what I mean. And the other kind of lessons, I would say, the generic lesson is that at the beginning, make sure you have metrics for instance, if you're building tools for product engineers, make sure you build metrics since day one, metrics of adoption. Say, okay, you go to a team and say, build a fantastic CI/CD system. What the team kind of has the instinct to do is just go and do it. And then we'll do metrics about the adoption later on. So I would say the hard lesson here, this is a real metrics of adopting of deployments on SPINNAKER, one of the CI/CD, actually CD tools that some of the teams are working on, which is awesome. So this we kind of did a bit later in the game, right? So, but it really helps, I would say. That's the outcome. And do I have? Yeah. So okay, we've got the teams. You have these basics in place. How do you make them grow to billions of requests, or handling billions of requests, or having thousands of developers use your tooling, internal developers or engineers? Well, I would say that what they did was do systematic analysis. That's kind of sounds very cool, but in the end, it's thinking about what the challenges of the teams are to deliver these billions of requests and handling the hundreds of millions of users. Is that okay? Let's sit down and see what can make the teams grow. And this is not saying, okay, we need more people, or the engineers don't listen to us, or whatever, right? This is not a proper analysis of the situation. You're not helping the team. I would argue that you're not helping the team by saying we need more people. I'm going to senior management and asking for more resources. Is this an analysis we're proud of as engineers? No. I would argue, if you like. So, for instance, this example of after the last 3 years of doing this at Schibsted, and growing some teams and being quite an active part in growing those teams and managing some of them at some point, it's kind of what actually are the challenges for these people, and let's put names to it. And as you know, naming is quite a hard computer science problem, so it actually is is significant to name the problems a bit more specifically that we are overloaded. Right? So I would argue that this analysis helps the teams deliver these billions of requests and handling these millions of end users and delivering tooling for thousands of engineers. Right? And I call them user focus, scalable knowledge, agile teamwork, and engineering mentality. just kind of a bit random names to make it easy to remember, but actually to focus on some of them at some point. You cannot solve everything at the same time at this, right? So I would like to explain a bit more about them, right? So each individual one. So user focus. This is the root of all team value. And user focus here is actually, if we're speaking about the infrastructure teams, for instance, low-level teams and so forth, and DevOps. I would like DevOps is kind of across the board. So infrastructure teams, for instance, the user, the engineer that uses your stuff is the root of all value. This is where everything comes from. It's not a technology, it's not a tooling. This is the root of where it comes from. And it fits the rest of the stuff, right? So you kind of do engineering to solve the user problems. Not necessarily what the user asks for, what the real problems are, but you need evidence. You need to kind of talk to the user anyway, right? And so forth. And then from that you build knowledge that you have to scale. And then you actually have the team to be very agile and do a lot of teamwork, right? And I would say the single best way to get that user focus is doing joint projects. You know, I don't know, you have a new infrastructure team. The best single thing you can do to get that team engaged with other engineers is to do a joint project, right? This is the very fast way to success for a new infrastructure team, right? And I would argue other low-level teams, engineering productivity, developer relations, things like that, extremely, extremely successful. So, you know, and usually it's a hero-driven. So you have a hero in some other engineering team, a product engineering team that is like, I love Kubernetes. This is the typical, or Prometheus, right? I would like to sit down with a team that is going to set up Prometheus and work together. Or I really like your product, your internal product, but it's lacking one feature. So what engineers can do is, instead of just asking about that feature, is sit down with you for a month with your infrastructure team and just develop that stuff. This is amazing. It's one month of effort. But then the product engineer comes back to the original team with a lot of low-level knowledge, a lot of trust in the infrastructure team. Can do PRs, can fix some issues on the back end, he himself or herself, right? And also the infrastructure and the low-level team gets really a feeling of what the user is like, right? Not necessarily as a person and so forth, but also what the needs are, because you work together. This is, and I would say that the takeaway here is that make this systematic. Acknowledge this is actually awesome, and then make it happen on a regular basis. Think about it. So we kind of do a lot of work to make these synergies happen in a more systematic way, as opposed to hero-driven. You still have the heroes, right? And that point, right? So that's the one. So structured support, right? That is very, very, very basic. So chat systems are not good for support, okay? Maybe if you probably already know, but we actually have gathered data, and it is actually much better to do, I don't know, some old ticketing system. This is actually a copy of a page of what we call the help center. This is for the cluster management team. Zane was speaking about this yesterday. So, do you need urgent help? Do you need critical help? Is everything down? Very, very clear instructions on what to do ticketing about and how to request help. Not chatting on Slack. Slack is awesome for other things, not support. Scalable knowledge. We halfway, okay. I'm going very fast, which is good. So scalable knowledge, right? So we have a lot of knowledge in the team. We did a lot of awesome interviewing. We have been growing the team. The team is sitting together with the user, which is fellow engineers from product teams. Okay, but it's very easy to fall into the kind of siloing within the teams and actually within teams of teams. And this is something that I don't know, I'm a bit obsessed about, to say, okay, it's awesome to build that knowledge, but how we make it scale, right? And the funny thing when you work in such an environment where you have literally 1,000 or 2,000 developers across the globe. I would love to go to Brazil to talk to the engineers there. I hope to do it one day. But this is not economically feasible, nor is ecologically responsible. Right? Even if you have the money, this is carbon footprint, which is not good for the environment. And this is a reality. So you cannot meet every single developer let alone just meeting them, let alone kind of have an ongoing relationship. You cannot do joint projects with all of them. It's not possible, right? Even though it's quite effective. Do it for a few, especially at the beginning, and then do it from time to time, but you cannot do it with everyone. So you scale your knowledge, but not, we are used to scaling instances, but knowledge. Treat this as a first-class problem. This is not some afterthought. One of the issues that I would say we're facing, probably all of us, is which I'm kind of, because I come from the media industry, I'm kind of a bit shocked about, but it's actually a real challenge. We don't have, I would say, not a clear answer for it, is that one of the problems is scaling knowledge at large organizations, and when you have multiple teams and stuff, is that you have one of the root cause analysis of this is that we have multiple sources of information. This is a quote from myself, probably, I don't know, maybe it's somewhere else, but this is from which is a bit similar to the email one, which is all applications evolve into content management systems. And if they don't, they are replaced by content management systems. You take, I don't know, GitHub, which is an awesome tool. In the end, there's lots of content, not only code, if you like, but lots of content in GitHub, in PRs, in peer discussions, in issues. It's a content management system, and then it handles code. So, from time to time, right? You have wiki systems, you have ticketing systems, you have documents, you have emails, you have shared documents, you have PR discussions, you have code issues, you have to-dos in the code, you have email attachments with content, you have markdown all over the place, you have YAML files, you have a source, you have a source that doesn't have comments, but it's still content, and you have actual content is in the production server somewhere. So your production servers are content management systems, right? Face the reality. This. And if they are not content management systems, they will become ones. And they also do handle production code as well, right? I'm quite shocked in a sense. It's a bit of a strange situation. It's like the content industry has been facing this problem for a long time, right? A media publishing industry, and we have some publishing, products as well. And, either Netflix or things like that, they handle digital content distribution multi-channel for a long time. And one of the things that these people do, and I work in that industry at the BBC or the local Catalan broadcaster, is that you separate two concerns. One is the content management itself, and the other is the content publishing. And this is kept separate. And don't go to journalists and, a personal experience, and tell them, you have to input content 2 times. They will not be your friends. They'll be your colleagues, but they will not like you, right? Which makes a lot of sense. So why are we asking with our engineers to get the same input in wikis, input it in PR requests, put it in a newsletter we want to send internally? This makes no sense. This is one of the root causes of the problem of scaling the knowledge. And then once you have the content publishing system in the media industry, you publish it everywhere. You publish to all sorts of devices, sort of channels, to Twitter, to Facebook, to your digital newspaper, etc. Take this as a root cause or problem of scaling the knowledge within your organization. And think about people like, digital journalists or media industry. They have a lot of code and a lot of knowledge about this. Still a page from that. Okay, the other one is the video stupid, which is, video is awesome on the internet as a digital content distribution system. Do screencasts of stuff for concerts, for training. Works really well. The other one is Agile Teamwork. It's kind of worrying about the process. This is a bit kind of a more obvious one, if you like, and using Agile methodologies is, I would say, strongly recommended. Even if it's DevOps, if it is infrastructure, it doesn't matter, right? It's like, and those processes, you have agility and the agility manifesto and all the methodologies there, but actually generates a lot of data. I will not go into this. There's like awesome team at the Shipster that's working on this, but you're generating a lot of data of the development, deployment process and operations, metadata, that is being thrown down the drain. There's a lot of, again, feeds back to what we were saying before, right? Which is you actually generating content all the time that is being not analyzed, it's not being collated. So you're doing it for your business with your amazing Spark stuff, but not for your processes. I don't know. Let's think about it, right? So I'm afraid I don't have solutions for this, right? And there's like colleagues that know much more about this than I do, but this is something to think about. Recognize as an issue and kind of work on. The other one is that DevOps, right? We all I would say that many people say DevOps means that the developers need to do operations. But actually, I must come from a software engineering. I'm a software engineer myself, so I kind of think about the operations people have to do development. It's, it goes both ways. But in the sense that this is a metric that teams are quite keen on, which is what is the ratio between what is considered operations and development? Even if it is a low-level infrastructure team, should not be all operations, I would argue. This is quite an important metric. You should track continuously. And I don't know, there's many ways of doing this, right? But for instance, I would tag the user stories if it's development or operations, and then kind of do some metrics about it. I would recommend that this, kind of take a look at this because it's quite, you'll be surprised, I would guess. Right, so the other one is dog fooding. This is more for a team, but also a team of teams, right? So I have a few infrastructure team or low-level teams. It's really important they use each other's tools. And even within a team, you have pieces of code or like favorite libraries or scripts that people kind of create within a team. Because I would say that it's surprising to see more than once is that, I don't know, this is a made-up example, right? It's not from the storage team we have or anything like that. It's like, oh, we're offering these storage services like, I don't know, Cassandra, et cetera, and these scripts to deploy, Postgres. We're not using it ourselves because we are special. This is a big, fat red flag. Not the end of the world. Okay, fine, don't worry. But this is a warning sign. You're not using your own products. This is in product development. This is a big warning. This is critical to success, and actually it's very useful. So you have a team of teams of infrastructure, for instance. Go and ask your sister teams why you're not using my awesome CI/CD system. If they are good sister teams, they'll tell you it sucks and why. Extremely good direct feedback. This is gold. And it's so important that we're actually working on a metrics for this. We call it the fooding metric. This is a simplified version to say you either adopt it or you give feedback of why it's not adopted. And this is our +1. If you don't do any of those things, it's 0. Multiply by the number of services. And this is the dog fooding metric. Important. It really helps. I would say the key one, and this is probably my software engineering bias, which is kind of something that it's actually a bad name for it, the engineering mentality, but hopefully that'll get the idea across, which is, it's like, for instance, and this is an example, that could be the opposite, right? So you have a DevOps from developer's perspective is actually engineering mentality in the sense that some of the problems of developers can be solved by being a bit more operations. This is engineering thinking, right? To say, okay, with a bit of operations knowledge, I can actually make my life much easier. So this is, I would say, that where DevOps comes from. So this is kind of a bit of the opposite, if you like. It's like traditional operations-heavy team. Or when you do low level, that's quite important, right? So, okay, how can we kind of tackle this? Make a bit of development to make our life much easier, right? Important. And usually the alternative when teams are facing like that, and not only in the DevOps context, I would say, is that we need more people. We are overloaded with work, et cetera, typical challenge. We need more people, or, there is actually a pattern, which is more in the low level, but also in the software engineering in general, is downloading software, right? Or adopting stuff you download from the open source, which is awesome, right? And I'm a big fan, and I showed you the GitHub timeline, which is public commits, right? So there's nothing wrong with this, but this is the typical answer for some engineering challenges, right? Which is, I personally call it download and play. And I like to call it that way because if you read about addiction or about game design, like video game design from professionals, the patterns there is like, it's exciting to do this. It's why, one of the reasons why we love technology. I love technology. Like you get new stuff, you play with it in a professional way, and then it kind of gives you value. This is amazing. This is a pattern that kind of you like, you love it. That's why a part of the reason we are here. And and this is a simplified version. I hope you get, I get the message across. But it's a download a piece of software, you integrate it, you get instant value. Awesome. You'll add alerts, metrics, documentation, and you move on. This is a typical. I'll do it all the time. So I've done it many times, and this is extremely successful. We should do this as much. I wouldn't say as much as possible, but this is progress. You don't reinvent the wheel. Many benefits. But there is a slight problem with this. You work the same skills over and over and over. Analysis, integration, monitoring, etc. Which is awesome, it's great. And it's actually, exciting. And it delivers value to the business. Self-reinforcing. It works, it's exciting, it delivers value. Okay? But you're working on a specific set of skills only. Important, extremely important skills, but only those. So you have things like the endless migration risk. Because, after a while, things are not so rosy. I think we've all been there. Maybe it's missing some features, maybe it's not exactly, or I don't know, or it doesn't scale. And, more than once, the solution is actually downloading something else. Something new comes about. It's actually more modern. It has more modern ideas. It has learned from some of the mistakes. Awesome. But we end up spending a lot of time migrating. If you do some analysis on what the heck are we doing, migrating. And migrations are necessary. And again, we deliver value to the business, but it's migrating. So what do? Are you an engineer? No, I'm a migration engineer. Let's acknowledge this problem and this pattern. It's also self-reinforcing as well. And okay, so show of hands, who's experienced this? Okay, a bunch of migration. Only 2 people or 3? Really? You need to be consultants. You'll make a lot of money. Right? See, this is very common. Right? So you do a bunch of the migration, but there's always leftovers. Small system, someone else in another country that you never met before that is not migrated. But you're okay. You do, and you deliver value. But okay. Right? And this is kind of looks silly, but you put it here, it becomes obvious. And I would say, I don't know. I've been in this situation personally as an engineer many times. And you put it here, and it looks, I don't know, it looks a bit silly, right? What the heck? And guess what? Oh my goodness, right? And actually, you look at this. Isn't it the feeling you get when you kind of start afresh, you start working? And then after a while, you kind of feel your workload kind of growing. And in kind of curve like this. I don't know, maybe it's random, maybe not, right? And okay, and there's always a time where fun comes. The big crisis. People leave, there's a big incident. Well, it's okay, of course. And again, the local perception that you are delivering value all the time. And again, it's great. Don't reinvent the wheel. Don't develop everything from scratch. It makes no sense, right? But you have been drawn, and I've been in that, right, into a self-reinforcing cycle of value, and migrate. So I've been probably more of a migration engineer than other kinds of engineer in my life, right? I'm happy to admit. So okay, but this is I would say this is the reality. Let's acknowledge this, and okay, let's think about things to mitigate this problem, right? One option, and this is for, I would say that low-level teams, but also engineering teams, like at any level of the stack, is, okay, sometimes maybe we download, play, and become domain experts. There's nothing wrong with this. To say, okay, this piece, This, I will just go really deep into it, right? This has a higher risk. This has risk, right? So you say, okay, I will spend engineering time on this and my, my own team time and myself, okay, and I could have moved on. But, risk and reward are related, right? So if I do it well, I would argue that you get actually awesome rewards. And actually lateral rewards. I'll explain a bit more about that. And the challenge here is choosing what to do, what to deep dive on. We cannot do it for everything. It's madness, right? And I would say examples of this that are from Schibsted teams, some of the low-level teams that I've been quite heavily involved with. And actually we heard Christian and Zane, previously about examples, right? So you've been to two of them already. One is content delivery, something as simple as delivering images to end users. This is one of the low-level services that is most mature. It delivers billions and billions of image transformations before caching. Then if you add the CDN, it's hundreds of billions, right? So something as silly as that, the typical thing is you go to GitHub or you build some kind of a simple script, you deploy it and you move on. It kind of works, but you have to deliver it to 100 million users. It will fail. It will have glitches, it will kind of have some downtime, it will have some lag, some latency sometimes. You say, this is core to my business. If I have a website with no images, it's not good. If the images are slow, the latency is extremely critical to what I do. In Schibsted, it's extremely critical. We develop such a system, and we fine-tune it to metrics like this. This is availability of the newest version. This is between 1,000 million requests to 500 million requests in a week. This I took from the metric system, I think Monday or something. Right? Sometimes it's a bit lower than that. Sometimes it's a bit higher. It's mostly a bit lower. But this is not a special week. This means that you really kind of, what you get from here is that, okay, maybe you tune this, but the tuning gives you a set of skills you don't usually develop to make all these nines of availability. And these skills you can apply to other problems. So what are you, a migration engineer and an optimization engineer? Well, cool. And you can use this not only for image delivery, for other things. And we are actually doing it, I don't know, and the team is working on Kubernetes ingress controllers. Well, if you have those skills that you developed here, instead of having moved on to something else, you can exploit that. And I'll post a link to a chat about the system. This is the architecture. Again, nothing special. Well, it's pretty cool. But, on Amazon, using some Amazon tech and some Netflix OSS, et cetera, et cetera. I'll post a link on a talk, half an hour, that kind of goes deeper into this. But actually, we have Zane's and Christian's examples of other kind of deep diving into a problem, right? Another example is the Cassandra, right? So the storage team, said, okay, the recovery of the biggest Cassandra cluster takes more than 12 hours. So if you have a total data loss because the Cassandra explodes, which is not likely, right? But there's a human error or something, will be, the messaging system, the biggest one we use, will be offline for half a day. What? Not good for the business. No. And you recover the data, right? But, this is a problem. So the team has been building on diving deep into it and say, we'll build a system that handles the same tens and tens of terabytes, less than 100 terabytes, but, it's quite a big one, or relatively big for some people, at least, fairly big, I would say. Something that's 4 times faster, and hopefully will make it even faster, right? So, 3 hours is a long time, but it's not half a day. Okay, so, and in the meantime, you develop skills about Cassandra. And you could easily say, we have a backup system, and it works. Well, investment. And there are, and another even better alternative is download, play, and contribute. This gives you a lot of benefit as well, but you have to choose very, very wisely. So not only diving into the problem, but actually developing stuff like the networking abstraction layer that Christian was talking about. It's quite hard to choose. But this is an example, and I'll post some talks about it, amazing talks by people in the delivery team and so forth, like the SPINNAKER, which is one of the continuous delivery systems that we use. But at the beginning, it didn't support Travis, which is a build system that it's heavily used at ships. Well, the typical solution, but it doesn't support Travis. It's a big piece of software. We'll have to use something else. And there's all other solutions that also work and are integrated with Travis. So we do another migration. And then the other system, I don't know, Jenkins or whatever, which is fine, it works well, it would have other problems. Maybe it doesn't scale. Maybe it doesn't have some whatever reason, right? All software has issues. Then we do another migration to something else that comes up. Another option is, OK, we develop the Travis support. And we release the open source, so it's open source, and now it's completely integrated. This is a random screenshot, by the way, but it doesn't show the Travis integration, but it doesn't matter, right? So to get the idea, this investment pays off heavily. And again, you cannot do it for everything. You shouldn't do it for everything. You should do it for only very, very, very core stuff. But this is worthwhile. You test the skills, and you develop the skills that you don't usually do. And then, I don't know, I think it's a very worthwhile objective to be fed. And there's other examples, right? And there was at the previous talks about, and I'll post some talks online, and again, this is not unique to Shipstead or anything, but it does pay off this investment. So I would encourage you to try it. And again, the benefits from this, especially contribute, but the deep dive as well, right, is be very aware that by doing a specific approach that delivers a lot of value that you should do 95% of the time, only handles a specific set of skills, right? So, yeah. So you might get a competitive advantage out of it. Very, very high availability, maybe high performance of this skill set. And I would bet that you will. Not always, but you will. And an important one is that you become an authoritative source of support. If you are a committer to SPINNAKER and people ask you questions about how to run it, you know what you're talking about. Not just you downloaded it and made it work. And of course, managed services. This is awesome. You should do it as much as you can. So, there are brilliant services out there. Just use them as much as you can. Just pick some stuff that is core to your business and use that to practice skills that you need that are not just analysis, integration, operation. So, takeaways. That's the end of the talk, right? Non-technical fundamentals. Journalism, history, economic history, emerging behavior, psychology. There's amazing wealth of content that it applies to you. So I read this book about addiction, right? So about self-reinforcing cycles, and I was surprised to recognize myself in many things. Like we love technology, so you see, there's things in common there, and also psychology, economic history, and things like that. Right? So please do brush up on them if maybe you are, already, on top, or maybe not, right? So I would encourage you to check that out. To grow your teams to those billions of requests, analyze the problems in a structured way, like we do with engineering problems. Name things. Made up the name. The names here are made up of all the challenges and things to grow. It doesn't matter the name. Well, it does. Like it's a big problem. And then kind of start to analyze what the issues are, what the metrics are, what data you can get, what the root causes are for those problems. And then I would say that handle your internal users, like your engineers, like you would do the end users. Give them as much love as possible. Use product management techniques. There are plenty of literature about that. Not just agile methodologies for development and so forth. Scale your knowledge, not only your instances, right? And analyze that as a first-class problem. And dogfooding is amazing, actually. It's a very good technique. And, if you manage to choose one single thing that you can contribute to, it will pay off 10 times. Okay? And finally, embrace self-criticism. There's a bit of a generic one, but actually this is a bit self-criticism, right? It's like, okay, what are the teams, what as a manager I can help them with, right? So this is not saying, give me more people. This is actually self-improvement, if you like, in a sense. So that's it. That's the link of the slides. There's a couple of comments missing. I'll just commit now. I also posted some links on some of the talks I was mentioning. But that's about it. So thanks for your time. Any questions? So maybe we have time for one question or something. Anyone? No?
Come on, some questions, guys. I mean, like, this talk was amazing. I mean, I feel like I identified with so many things you said.
No? Oh, there's one. OK.
Hello. I have a question. Earlier at the beginning of the talk, you mentioned that you cannot train everybody. How would you go about that?
That's a good question. So I would say that one of the takeaways there is that basically this is a content scaling problem, right? So your content and knowledge scaling. So take techniques from the digital media industry. A video is one of them, right? So you do a video once, it takes a lot of effort, not so much actually for screencasts, and then it becomes viral. So, well, that's a way to actually spread the knowledge without you doing anything that other than the initial investment, right? So I wouldn't say they have a recipe for you, but that's basically copy or take a page from the content industry. It really works because they have been doing this for a long time. Okay, one? Yeah, okay. We're kind of on time, right? So, ish. Okay.
Hi, thank you for a great talk. Question, what tools do you use to measure the internal adoption services?
This is custom built for every service, but I would say that the critical things to do is, you can deploy it put it in a metric system, right? It doesn't matter, but we usually do a team adoption, how many teams, how many users, and users by users I mean engineers, and then how many kind of transactions, right? I don't know, deploys, commits, PRs, etc., etc. So, and then you do correlations or things on them, right? So in the end, the tooling is a bit less important, but make sure that all the content you generate about the process is not lost. You put it in some kind of metric system. I don't know, open source or as a service or whatever.
Okay, thank you.